graph the solution set for the system of inequalities. We are given 2x minus 3y is less than 1, and also x plus 2y less than or equal to negative 2. So the strategy here will be to graph both of these inequalities on the same coordinate plane, and where these two inequalities overlap, that area will be the solution set for our system of inequalities. So let's graph each of these inequalities independently, again on the same grid. So we'll start with 2x minus 3y. 2x minus 3y is less than 1. And I'm going to solve this inequality for y, get it in the form of slope-intercept form so it's easier to graph on our number line. So we would have a negative 3y is less than, and we're going to subtract 2x to the other side, giving us negative 2x plus 1. And now we'll divide all the terms by negative 3, and since I'm dividing by a negative, I need to remember to flip the inequality symbol. So dividing everything by negative 3 would give us y is greater than negative 2x divided by negative 3 is a positive 2/3 x, and positive 1 divided by negative 3 would be a negative 1/3. So now we will graph this inequality. Y is greater than 2/3 x minus 1/3 on the grid. Our y-intercept is negative 1/3, so I'm going to go down just a little bit, about a third of the way down to negative 1. And from that point, we will go up 2 units, to the right 3 units, up 2 units, 1, 2, to the right 3. I locate a second point. And since the inequality is strictly greater than, not greater than or equal to, strictly greater than, we need to draw a dashed line, broken line, through our 2 points. And now we need to determine on which side of the inequality should I shade upon. And again, there's 2 ways of looking at it. If you have your inequality solved for y, if it's a greater than situation, we will shade above the line. If it's a less than, we shade below the line. So since it's greater than, we will shade above the line. The other method that you could use is pick a test point. We could choose the point 0, 0, and when you let x be 0 and let y be 0, this will be a true statement, also telling us that we need to shade above the line. So we will have all of this area shaded for the first inequality. Now we'll repeat this process for our second inequality. And our second inequality is x plus 2y is less than or equal to negative 2. And again, we will solve this inequality for y. So we'll start by subtracting x from both sides. So we have 2y is less than or equal to negative x minus 2. And now we will divide everything by positive 2. So no need to flip the inequality symbol since we're dividing by a positive value. Negative x divided by 2 would be negative 1/2 x, and negative 2 divided by 2 is negative 1. So here's our second inequality solved for y. It has a y-intercept of negative 1. Y-intercept of negative 1. And this slope says to go down 1 unit to the right 2 units. Down 1 to the right 2. Since it's an equal then, less than or equal to situation, we want to draw a solid line through our 2 points. Solid line. And this is a less than situation, so we will shade below the line. Or if I choose the test point 0, 0, substitute 0 for x, 0 for y, it will make this statement false. So I want to shade away from the test point 0, 0. So we would be shading all of this down here. And now the final answer to our problem, graph the solution set, what points make both of these inequalities true at the same time, will be where do our shaded regions overlap. And as you can see, our final answer will fall from here to here not including the dashed part, but then all of these points where our shaded areas overlap. So our final answer, folks, is the area in green, which would expand out, in this direction.